We train for a three-dimensional world using two-dimensional tools. A surgeon repairing a heart or an aerospace engineer calibrating a turbine is working in deep physical space, yet their primary training materials are still flat slides, hundreds of pages of technical manuals, and passive video screens. This disconnect creates friction. Reading about a complex mechanical procedure doesn't build muscle memory, leading to slower onboarding times and lower knowledge retention when employees finally hit the floor. The obvious fix is simulation-based training. Using extended reality, or XR, a combination of virtual and augmented reality, trainees can practice complex, high-stakes tasks in completely safe, risk-free environments before touching real equipment. While traditional training methods reach users quickly, a massive logistical wall blocks XR. Building custom, interactive environments usually requires heavy coding and an army of specialized developers. Because of this technical barrier, seasoned educators who understand the subject matter are locked out of creation. EON-XR operates as a cloud-based ecosystem designed to bypass that exact problem. It gives those non-technical creators a direct route to build immersive learning modules without needing to write a single line of code. The platform democratizes the technology by stripping away programming requirements, placing the power of XR directly into the hands of subject matter experts rather than just software engineers. To understand how this architecture works, let's look at how a trainer actually builds a module from a completely blank project. Instead of modeling objects from scratch, users import digital twins. These are exact, highly detailed 3D replicas of physical objects, like this engine turbine, dropped directly into the platform workspace. Once the object is placed, the creator uses a visual drag-and-drop interface to build the lesson. They can pull apart components, add informational tags, and design interactive learning scenarios simply by configuring menus rather than writing scripts. This manual design is supported by an integrated AI assistant. The AI helps automate the generation of content around the 3D model, structuring adaptive learning paths that adjust to the specific needs of the user. Tasks that would normally require a multi-month development cycle from a dedicated software team are compressed into a rapid workflow that a trainer can master in an afternoon. Building the simulation is only half the battle. Historically, the second major point of friction for XR adoption has been the hardware. Equipping an entire workforce with specialized, expensive VR headsets simply isn't feasible for most companies. This diagram illustrates how EON-XR routes around the hardware problem. By processing the environments in the cloud, the platform deploys the exact same content instantly across multiple platforms, from dedicated headsets down to standard tablets and mobile phones. This cross-device accessibility means massive organizations can deploy training anywhere, immediately scaling to the screens their employees already carry. And once engaged, the platform captures every interaction, tracking time, accuracy, and overall engagement. Educators take this incoming performance data and use it to spot where learners are struggling, refining their training scenarios, and precisely measuring true knowledge retention over time. By capturing every interaction, the platform operates as a closed-loop intelligence system, providing a data-backed audit of a training program's actual return on investment. When you combine rapid content creation with hardware-agnostic deployment, the impact at the enterprise level scales quickly. Hospitals are using these virtual simulations to run surgical teams through rare medical procedures, while smart manufacturing plants are standardizing complex safety protocols for thousands of workers simultaneously. There are still real-world logistical realities to navigate. Processing these highly detailed models across devices requires stable internet connections, and large organizations must manage and store massive libraries of 3D assets to keep the system running smoothly. Looking ahead to Industry 5.0, these systems are integrating deeper AI personalization and mixed reality tools. This allows digital instructions to be overlaid directly onto a worker's physical environment, making workforce development a continuous, seamless process. Advancements in spatial computing and metaverse-enabled environments are erasing the border between the physical world and digital information. The physical workspace and the digital classroom are merging into the exact same location. Removing the barrier to creation transitions learning from passive observation to active participation, allowing workers to step inside the information they once only studied.